So here we go with our final exam review. I'm going to start off doing the part that is Mod 12. Mod 12, which is sequences and series. That covers questions, I believe it's 1 through 15. Yep, 1 through 15, and then I'll do another video for the next section. So, question number 1, find the 52nd term and the explicit formula. So if I'm looking at this, to me it looks like they are subtracting 6, subtracting 6, subtracting 6. Now if they are adding or subtracting the same thing each time, we have something that is arithmetic. If it is arithmetic, here is the formula for the rule. Now this is something you may want to put on your little pink sheet for your notes page. A sub n is equal to a sub 1 plus d times n minus 1. Now just a refresher, a sub 1 is the first term and d is the common difference. So in this case, a sub 1 equals, a sub 1 equals negative 30, and d is equal to negative 6, because that's what they are adding each time is negative 6. So I'm going to plug that into here. That gives me a sub n equals negative 30 minus 6 times n minus 1. So now I'm going to simplify that. A sub n equals negative 30 minus 6n plus 6. Now looking at these, it looks like they're putting their n term last. So that means I have a sub n equals negative 24 minus 6n. Negative 24 comes from the negative 30 and positive 6. So this one has a minus 3n. I know it's not a. This one has a minus 6n. It could be the answer. That one has a minus 5n. That's not the answer. This one has a minus 6n. It could be the answer. So the next thing I need to do is find the 52nd term. So I need to find a sub 52. And how do I solve that? I take my rule and I plug in 52 for n. So let's see. Negative 24 minus 6 times 52 means that my 52nd term will be negative 336. That tells me that it's going to be what? B or D? Well, it's not D, therefore my answer has to be B. Okay, now number 2, given a term in an arithmetic sequence. So they are telling me this is arithmetic, which means I got that same stuff going on, that same formula. I've given the a term and the common difference. Find the 52nd term and the explicit formula. So I'm going to start off with the formula. That would be a sub n equals, I don't know a sub 1 because they gave me the 12th term, plus d, d is negative 4 times n minus 1. So that's not quite enough information to help me get my answer, but I can plug in this information. That right there is an n value, so I can plug that in here. And that right there would be our a sub n value, which can be plugged in here. So negative 67 equals a sub 1 minus 4 times 12 minus 1. Negative 67 equals a sub 1 minus 4 times 11. So just doing some algebra here. A sub 1 minus 44. I'm going to add 44. And a sub 1 equals negative 67 plus 44 is negative 23. So now, coming back up here, I'm going to plug in a sub 1 and the d value that I already had into the formula. A sub n equals negative 23 minus 4 times n minus 1, and do my simplifying. Negative 23 minus 4n plus 4, and when I combine my like terms, I get negative 23 and positive 4 is negative 19 minus 4n, and I believe that matches up. It's not A, could be B, not C, not D, so it should be B, but let me verify by finding the 52nd term. So A sub 52 would equal negative 19 minus 4 times 52. So negative 19 minus 4 times 52 is negative 227, and that does fit with the rest of B. So I'm good there. So here we go with number 3. Given two terms again in an arithmetic sequence. So we're still using that same formula from up above in number 1. So that's our A sub n equals A sub 1 plus D times n minus 1. Seems like that might be a formula you really want to make sure is on your note sheet. So I'm going to plug in A sub 18 first. So this is what I plug in for A sub n. I don't know A sub 1. I don't know D, but if that's my A sub n, I have to plug in 18 for n. Now I'm going to simplify that. That gives me 17.1 equals A sub 1 plus 17D. Now, the way I have this started is actually the long way of doing this. So I'm going to set up the other equation, and if you know the long way, this is one of your two equations that you're going to use the system of equations for. Your other equation would be 19.9 equals A sub 1 plus D times 32 minus 1. 19.9 equals A sub 1 plus 32D minus D. So that gives me 19.9 equals A sub 1 plus 31D. So if you do it the long way, those are the two equations that you're going to use to solve and get A sub 1 and D. You would set those up as a system of equations. Now the way I taught my class was we want to set this up as a point. We want to call this 18 and 17.1. And this one we would set up as 32 and 19.9. And when we have 2 points, we're actually going to use the slope formula because the slope formula gives us that value right there. So the slope formula is our y2 minus y1 over x2 minus x1. And that gives us our slope, but in our case it also gives us our d value because our d value is acting like a slope here. So I'm going to take 19.9 minus 17.1 and put that over 32 minus 18. So 19.9 minus 17.1, and that is 2.8. 32 minus 18 is 14. Now we really don't like a decimal in a fraction, so let's just go ahead and divide 2.8 by 14, and that gives me 0.2. Now from there, to me it looks like if all these are 1.8 and that one's 0.2, it looks like A is going to be my answer. But let's just verify. If I go back to that formula, I know A sub n is equal to A sub 1 plus 0.2 times n minus 1. The way I find A sub 1 now is I plug in one of these 2 points from the beginning. So if I plug in the first one, 17.1 equals A sub 1 plus 0.2 times 18 minus 1. That gives me 17.1 equals A sub 1 plus, let's see, 0.2 times 18 minus 1, or 17, plus 3.4. If I subtract 3.4, A sub 1 equals 17.1 minus 3.4. That gives me 13.7. So if I plug in 0.2 as my D value and 13.7 into here, hopefully I get 13.5 plus 0.2n. Let's check it. Let's see, A sub n equals A sub 1 plus D times n minus 1. That would be 13.7 plus 0.2n minus 0.2. Combining my like terms, that does give me 13.5 plus 0.2n, and that matches up with A. All right. Find the 8th term in the explicit formula. Now this one is not arithmetic because they're not adding or subtracting the same number each time. What I notice here is that they are actually multiplying the same number each time. What are they multiplying by? They're multiplying by -3. So they're multiplying by -3 times -3 times -3. Another way that you find that for a geometric formula is, or a geometric sequence, you take the second term and you divide it by the first term and figure out what you get. Then take your third term, divide it by the second term, see what you get. Take the fourth term, divide it by the third term. Always taking a term and dividing it by the term in front of it. If you're getting the same number each time, that's what tells you it's geometric. That also tells you that that is your R value. And R stands for the common ratio. So, new formula here. That was one that you needed to put on your sheet. Here's another one. Here is your geometric formula. Geometric explicit. A sub n equals a sub 1 times r to the n minus 1. Now, a sub 1 is still your first term. R is your common ratio. So here, a sub n would equal, the first term is 3 times, my r value is -3 to the n minus 1. Which one of these answers has that? 4 times 5, 4 times -3, 4/5 times 5, 3 times -3. I should have D as my answer. Let's verify by finding a sub 8. All I'm going to do is take my formula and plug in 8 for n. So that gives me 3 times -3 to the 7th. Be careful how you plug that in. 3 parentheses, -3 to the 7th. Do not multiply the 3 first. You have to take the exponent before you multiply the 3's. Gives me -6561, and that does match what's going on with D, so I'm good to go there. Okay, so here we go on number 5. Another geometric sequence. So we're still using that a sub n equals a sub 1 times r to the n minus 1. They don't tell me what a sub 1 is or what r is. And unfortunately, I can't use that slope thing because it's not arithmetic. So I have to start off by putting 216 in for a sub n. And when I plug in 216 for a sub n, I plug in 4 for n. So if I simplify that, I get 216 equals a sub 1 times r cubed. And do the same thing over here. 36 equals a sub 1 times r to the 3 minus 1. Simplifying that gives me 36 equals a sub 1 times r squared. So I have two equations here. Now, my recommendation is take the one that has, what is it, the higher r value? Higher r value. I want to leave the higher r value alone. What I want to do is take the smaller r value. So this one's r to the third, this one's r to the second. The r to the second is the one I'm going to deal with. I need to get a sub 1 by itself. Now you can actually do it in either formula. You can get, or in either side, you can get a sub 1 by itself. It just, it just tends to be easier if you get the smaller one by itself, because then you don't need to worry about negative exponents or anything. Sorry, not dividing by a sub 1, dividing by r squared. So a sub 1 equals 36 over r squared. So if I come over here now, I'm going to take that and I'm going to plug it in for a sub 1 right there. So 216 equals 36 over r squared times r cubed. Now that's r cubed over 1, so when I multiply those, I get 36r cubed over r squared, because 36 times r cubed is 36r cubed. R squared times 1 is r squared. What happens when I have r to the third over r to the second? Well, we get some canceling there, and I just am left with 36r. So if I divide by 36, I get r equals 216 divided by 36 is 6. So there's my r value. Now I can take that 6 and I can find a sub 1 by going right back here. 36 over 6 squared is going to equal a sub 1. Well, 36 over 6 squared is 36 over 36, which equals 1. That's my a sub 1 value. So I need to find an equation that has a sub 1 as 1 times 6 to the n minus 1. And it might look like that because that would imply that there's a 1 in front there. So let's see, does this one fit that? A does. Does B fit that? Nope. Does C? Nope. Does D? Nope. Let's verify that a sub 8 is correct by plugging in 8. That would be 6 to the 8 minus 1, or 6 to the 7th. And let's see if that number up there is 6 to the 7th, 279936. It sure is. So my answer for number 5 is A. Now, one thing I do want to point out about this last question is things worked out really nicely because this became an r to the first. So all I had to do was get r by itself. If right here I had something different, for example, if I ended up, after I reduced everything, if I ended up with something like r to the third equals 125. If when I simplified I ended up with something like that. The way I get r by itself, remember, is you have to take the cube root. If you have r to the third, you have to take a cube root. The index has to match the exponent. That would give you r equals 5. Okay? If you had a fourth root or a fourth exponent, you'd have to take a fourth root. If you had a squared exponent, you'd have to take a square root. Make sure that you are aware of how to get r by itself if you have an exponent other than what we ended up with there. All right, next 3 questions. We need to just determine if it's arithmetic, geometric, or neither. So I'm going to start off with testing to see if it's arithmetic because that's the easiest. And that's just seeing, are they adding the same thing each time? So negative 2 plus what gets you to 6? That's plus 8. Is 6 plus 8 equal to negative 18? No. Therefore, it is not arithmetic. I can eliminate C as a possibility. It's either geometric or neither. If it's going to be geometric, I need to set up my fraction. So I have 6 over negative 2. That gives me negative 3. Next one would be negative 18 over 6. That's also negative 3. This is looking promising. Let's check the rest. 54 over negative 18. That's also negative 3. And negative 162 over 54 is also negative 3. So guess what? It's not neither. It is a geometric. Number 7, let's start off with arithmetic again. This is plus 1. That is definitely not plus 1, it's plus 4. So that does not help me. It is not arithmetic. Geometric, I would take 2 over 1, and then I would take 6 over 2. And since those two already don't match, I know it's not geometric. Because if it was geometric, those would match. Therefore, I'm left with neither. And number 8, I'm going to see, are they adding the same number each time? Negative 12 plus 10 equals negative 2. Does negative 2 plus 10 equal 8? Yep. Does 8 plus 10 equal 18? Yep. Looking good here. Plus 10 again. We have arithmetic for number 8. Okay. Now we have write the recursive formula. Now before I can write the recursive formula, I need to identify, is it arithmetic or geometric, or potentially neither. So I want to see, this one they are adding 25 to 33 would be plus 8. 33 to 41 would be plus 8, I think, again. That one is also plus 8. Oh, good. We have arithmetic. So, arithmetic, recursive. Remember, on the other side, it was arithmetic explicit. Arithmetic recursive is a sub n equals a sub n minus 1 plus d. So since I figured that out there, what's my d value? My d value is 8, so my formula is going to be a sub n equals a sub n minus 1 plus 8. That one matches, doesn't look like any of these others match, so it should be A. Let me verify that a sub 1, oh, I don't need to verify a sub 1. When we have recursive, we have to provide a sub 1, and I think we talked about that when we learned this. That because arithmetic says that to find a term, you have to use the term before it, we have to be given a starting value, otherwise we can't find a term. So, there we go with that guy. Let's see, what have we got here? Is this arithmetic? That one's plus 4. That is not plus 4. That is plus 12. So let's try geometric. 6 over 2, that's 3. 18 over 6, that's 3, looking promising. 54 over 18, also 3. So we have geometric. So we need the geometric recursive formula. If it does not say recursive in the instructions, they are just looking for a regular explicit formula, which is the formula we learned above and on the other page. So geometric recursive is a sub n equals a sub n minus 1 times r. So a sub n equals a sub n minus 1 times, what's my r value? Looks like my r value is 3. So let's see. And again, they have to give you a sub 1. A sub 1 is 2 in all these, so I don't need to worry about anything there. Interesting thing. Those ones were all 2 except that one, or all 25 I should say. So that should have been a clear giveaway that a sub 1 wasn't 23. So let's see, times 1/2, nope, times 3, times 4, times 2. My answer here is B. Okay. All right, number 11, evaluate each arithmetic series defined. This is our sigma notation. So what this is saying is if I were to do this the long way, I would plug in 1 for m and get a number. Plug in 2 for m, get a number. Plug in 3, get a number. 4, 5, 6, all the way up. 13 will be the last one I plug in. I would get that number and I would add that list of numbers together. That's what they're asking for here. I can always use that method if I forget a formula. However, I shouldn't forget a formula because I should write it down on my paper. Now, if you notice, this looks like that whole mx plus b form, which makes it arithmetic. And if I wasn't quite sure, I could plug in 1, plug in 2, plug in 3, get the first 3 or 4 terms, and verify just like we were doing up here, whether it was arithmetic or geometric. Okay, so arithmetic, how do I find the sum of an arithmetic formula? Well, if I'm going from 1 to 13, that's the sum of 13 terms. The way I find that is I find the first term, the number of terms times the first term plus the last term divided by 2. So if I have 13 terms, that means I have 13 for my n. A sub 1 is what I would get when I plug in 1. So a sub 1 is 4 times 1 minus 6, which is negative 2. Plus the last term, that would be a sub 13. That's 4 times 13 minus 6. That I don't know off the top of my head. 4 times 13 minus 6, 46. And then divide that by 2. So let's see. 13 times negative 2 plus 46 divided by 2 gives me 286 as my answer there. So S of 13 is 286. Now I have another one. You notice it's in the a sub 1 times r to the n minus 1. That makes it geometric. But again, you could come up with the first few terms and verify that if you wanted to, just like we did in numbers 6 through 8. Geometric sum, that's S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. So how many terms do we have? We're going from 1 to 7. That means we have 7 terms. A sub 1 would be this guy right here times 1 minus r, negative 6 to the 7th. I'm running out of room for my last parentheses there, over 1 minus negative 6. So let's look at this. We have to be careful with our parentheses here, especially since our r value is negative. So let's see, negative 4, parentheses, 1 minus, now I'm going to put the negative 6 in parentheses because it's the only thing that's getting that 7th exponent. So if you look at my calculator, it's being glared right there, I have 1 minus r to the 7th. That's what my numerator is. Divided by parentheses, 1 minus negative 6 and I get negative 159,964, and that is option A. Okay? So now we're into infinite geometric series. So infinite geometric series have a different formula. Infinite arithmetic series you cannot find the sum of. The reason why I know that both of these are infinite, first off in this one, there's an infinity sign at the top. On this one, it's that dot, dot, dot that tells me it's infinite. So, infinite only works if our R value is between 1 and negative 1. If it's not between 1 and negative 1, then we have no sum. Okay, so that's the first thing I need to identify. So, in this one, we have a sub 1 times R. So R is 1/2. And yes, that fits in there, so I do have a sum. My sum formula is equal to a sub 1 over 1 minus R. So that would be negative 5 over 1 minus 1/2. That's negative 5 over 1/2, which gives me negative 10 as my sum. This one, to find my R value, I would take negative 2, divide it by positive 1, gives me negative 2. Then I would take 4 and divide it by negative 2, that gives me negative 2. Negative 8 divided by 4, that gives me negative 2, so I have my R value. The problem is that R value doesn't meet my requirements. As soon as it doesn't meet my requirements, it's no sum. If you think back when we learned about that, we did some graphing, and when we had an R value that was like that, we started getting points that were just zigzagging. They were not approaching an asymptote at all. So we're stuck there. All right, and the last one of this section. To construct a pyramid made of bricks, the first row contains 1 brick. The second row contains 2 bricks. The third row contains 3 bricks. Don't make fun of my art skills, I'm a math teacher. And so on. If there are 40 rows of bricks, how many total bricks are used? So in other words, we have 1 in the first row, 2 in the second row, 3 in the third row, up to how many are going to be in the 40th row? Looks like if there's 1 in the first row, 2 in the second row, 3 in the third row, there's going to be 40 in the last row. And we want to know what is the total number of bricks used. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9, all the way up to plus 40 is what we're looking for. So in other words, I want the sum of 40 terms. And this is arithmetic because they are just adding 1 each time. So the sum of 40 terms, we used that formula on number 12, I think it was. Was it 12? 11? 12? Something like that. 11. Sum of 40 is equal to n times the first term plus the last term, oops, 40, divided by 2. So if I go to my calculator, that's 40 times 1 plus 40 divided by 2, whoops, cleared my calculator, 40 times 1 plus 40 divided by 2, that gives me 820. So they used 820 bricks for those 40 rows. Okay, so that's the end of the sequences and series section. Happy studying!